Hey, this video is going to go over solving multiple angle equations. These things can get pretty tricky, so just brace yourself. You're still going to need all of these equations from earlier, and I'm only going to be doing the one circled in red because I think this will probably take a little while. Okay, the first thing to know is that if there is a number in your B slot, it gets treated differently than if there's not a number in your B slot. So I'll show you what to do there, but that's the first thing you should look for. Like this one, I'm going to treat differently than if there was no number there, like number 10, for example. So just keep that in mind. Here we go. First one, secant 3x equals -1. So if I have a function like secant or cosecant isolated on one side of the equation, I flip it. So like I would instantly change this to be cosine 3x. And you have to flip -1, but it's just -1/1. It's just going to stay -1 anyways. All right. So now you're wanting where cosine 3x equals -1. This is when you can inverse cosine. And this one happens to be a quadrantal, meaning they're essentially giving you the x value, -1, and saying, what would the y value have to be? Well, it would have to be -1, 0 here, right? That's at pi. So I go like this. I go, only the arc cosine and cosine cancel. It leaves the 3x, okay? So 3x equals pi, but then you have to realize, like, yeah, it's pi, cool, but what if you did one extra loop? So like, what if you added a full loop, which is 2 pi? That would be 3 pi. That would be an acceptable answer. What if it was 5 pi? That would be an acceptable answer. So in order to account for this, like an infinite number of answers, you have to put plus 2 pi n, where 2 pi is your loop and n is the number of loops you would want. So like if you wanted 4 loops, you'd be adding 8 pi to your pi answer. So like 9 pi is an acceptable answer. All right, so you have to account for this infinite number of answers by doing plus 2 pi n. And the reason it's important is because now you're going to come through and you're going to divide everything by 3. So you're going to get your answer, x equals pi over 3 plus 2 pi over 3 n, like this. And so if you actually want to list all the correct answers, well, it's going to be pi over 3. But then you're going to be adding 2 pi over 3 over and over and over again until you break the domain. And the domain's from 0 to 2 pi. So anything over 2 pi, slam the brakes. So like pi over 3 would be an answer. I'm adding 2 pi over 3, so that'd be 3 pi over 3, aka pi. That would be an answer. And then this was 3 pi over 3, just so I don't confuse anybody. And then I'm adding another 2 pi over 3, so that would be 5 pi over 3. And then if I did one more, that would be 7 pi over 3, which is really 2 1/3 pi, which breaks my domain. So it's just these 3 previous answers. So you just keep adding whatever the increment is until you bust that 2 pi. Hope that made sense. Okay, let's move on. Okay, look at number 4. Sine of x over 2 equals -√3 over 2. All right, well, your function's by itself, so you can inverse sine here. So sine is negative. You need to be thinking, I have to be in quadrant 3 and 4. So I'm going to have an answer in quadrant 3 and an answer in quadrant 4. So it would be like this. Remember, only the inverse sine and sine cancel. It leaves that x over 2. So it'd be like x over 2 equals. Well, for quadrant 3, for it to be -√3 over 2, that would be 4 pi over 3. But then since it's not just x equals, I have to account for those infinite answers by putting plus 2 pi in. All right, and then I would have another one in quadrant 4. So that would be at 5 pi over 3. So x over 2 equals 5 pi over 3 plus 2 pi n. All right, now to finish this off, you have to cancel this divide by 2. So you're going to multiply by 2 on everything. And so you're going to get your answers of x equals 8 pi over 3 plus 4 pi n, and x equals 10 pi over 3 plus 4 pi n. Okay, well, now you have to look at what you're adding. You're adding plus 4 pi n. Well, that's instantly going to bust your domain of 2 pi here. So you don't really care about that plus 4 pi n. Anything over 2 pi n kind of thing, then you're not going to care about. So your answers here would be 8 pi over 3 and 10 pi over 3. And in regards, like, these are acceptable answers, but in regards to recognizing your domain, they're both above 2 pi. So just keep that in mind. All right, let's move on. We're going to jump to number 5. Now I've got 2 sine squared 2x equals 1. All right, this one's going to get kind of tricky. So 2 sine squared 2x equals 1. First thing I would do is divide by 2. So sine squared of 2x equals 1/2. The second thing I would do is I would root it. Now, when you root 1/2, you're going to get root 1 over root 2, which is 1 over root 2. And if you rationalize that, you would times by root 2 over root 2, and you'd get root 2 over 2. This is what you're used to seeing. So just keep that in mind. That's how I'm going to get there. All right, so I would root it. When you root something, you need plus minus. So you're going to get sine 2x equals plus minus root 2 over 2. This means since there's a plus minus there, it could be any of the 4 quadrants. So you're going to have answers in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, now you're ready for the inverse sine. It'll cancel the sine, but it'll still leave 2x. So you got 2x equals. All right, so in quadrant 1, that would be pi over 4 plus 2 pi n to account for the infinite answers. In quadrant 2, that would be 3 pi over 4 plus 2 pi n. Quadrant 3, that would be 5 pi over 4 plus 2 pi n. In quadrant 4, that would be 7 pi over 4 plus 2 pi n. All right, so now you're going to have to divide by this 2, and you divide everything by the 2. So it's going to look like this. All right, so you end up with x equals pi over 8 plus pi n, x equals 3 pi over 8 plus pi n, x equals 5 pi over 8 plus pi n, and x equals 7 pi over 8 plus pi n. All right. So now, just before I even start answering, please realize that when I say I'm going to be adding pi n, I'm really going to be matching my denominator. So it's really like adding 8 over 8 pi n. So here we go. My first answer is pi over 8. I then add pi n, aka 8 over 8 pi n, to get 9 pi over 8. And if I did it again, I would get 17 pi over 8, which breaks my domain from 0 to 2 pi. So you still have to follow those rules. You have to stop at 2 pi. All right, this next one, my first answer would be 3 pi over 8. And then I would add 8 over 8 pi. So I would get 11 pi over 8. If I did it again, I would break the 2 pi barrier. The third one I've got 5 pi over 8 plus 8 pi over 8 would make 13 pi over 8. And then same thing, if I did it one more time, it would break the 2 pi barrier. And this last one would be 7 pi over 8. And then add 8 pi over 8 to get 15 pi over 8. So all of these answers are what you're looking for. That was a hard problem. The next one's even more difficult. Okay, number 6 is going to be not so fun. And the reason it's going to be not so fun is because you are going to have to use those equations to the left in order to do it. So what I mean by this is you've got like sine u plus v right here. And you've got sine u minus v right here. You're going to have to be using these equations. So take your time, watch your plus minus signs, but this is what it would look like. It would look like sine u cosine v plus cosine u sine v. That was the first part. That was this part. Now there's a minus in the middle. So minus. And then I run the equation for the second part using this second equation right here. So that would look like this. And it's minus this whole thing. So I would open up a parentheses here. Sine u cosine v minus cosine u sine v. All right, so that's just the first step, replacing, oh, sorry, and it all equals 1. So just plugging in these equations. That's all I've done so far. All right, now I'm going to distribute this minus sign to both of these things. So it's going to become a plus here. It's going to become a negative there, and it's going to become a plus there. And the reason this is important is because now, if you look at it, these are like terms that will cancel. And so really, you're going to have cosine x sine pi over 4 plus cosine x sine pi over 4 equal to 1. So it's really like 2 cosine x sine pi over 4 equals to 1. And sine pi over 4, well, that's just root 2 over 2. And so once you get it here, you're doing really good. You're basically done. You would have to multiply this 2 times this root 2 over 2, and you would get root 2 cosine x equals 1. You would divide by root 2. You would have to realize that 1 over root 2 is the same thing as root 2 over 2. And then now you could inverse cosine and think about what quadrants, etc. So cosine being positive tells me that I'm in quadrants 1 and 4. So I'm going to have an answer in quadrant 1 and in quadrant 4. There's no number in my B slot, by the way, so I'm not going to care about the whole plus 2 pi n situation. I'm just going to inverse cosine this and go get my answers. So where cosine is root 2 over 2 in quadrant 1 would be pi over 4. And in quadrant 4 would be 7 pi over 4. And those would be my only 2 answers, and I would be done. It's just this part that makes that problem so difficult. I know that one was tricky. Let's keep moving. We're going to number 11 next. Okay, number 11. Number 11 is not too bad, but you will have to change cosine 2x. So here's what I mean. You've got cosine 2x plus sine x equal to 0. All right, cosine 2x can change to any one of these 3 equations. Now, which one do you choose? That's the million-dollar question. I would choose the one that when you replace it, matches your other function. So like I would choose the one with only sines. I would choose this middle one. So it's going to look like this. Cosine 2x changes to be 1 minus 2 sine squared x. then you've got your plus sine x equal to 0. So if you can make this jump, you're doing good. Now, you have to treat this like a trinomial and factor it. And to do that, you're going to want to have your square positive, this lead coefficient. So I'm going to switch sides with everything. I'm going to subtract 1, add 2 sine squared x. I'm going to minus sine x. And then I'm going to make it match on the same side. Minus 1 plus 2 sine squared minus sine. All right, so when I rewrite this problem, it's going to become 2 sine squared x minus sine x minus 1 equal to 0. And now I can factor this like a trinomial. Like that. And so if you can get here, well, there's no number in your B slot. So you don't care about the whole 2 pi n situation. You're just going to go solve each one of these equal to 0. So it'd look like this. I would subtract 1 and divide by 2, so I would get negative 1/2. Then on this one, I'd be like this. I would add 1. All right, so the one on the left can be inverse signed. The fact that sine is negative tells me I'm going to have an answer in quadrant 3 and an answer in quadrant 4. Where it's negative 1/2, it would be in quadrant 3, 7 pi over 6, and in quadrant 4, 11 pi over 6. So those are those two answers. And then over here where it's sine x equals 1, it's a quadrantal, so they're really giving you like the y value. So it would have to be at 0, 1, which is at pi over 2. But you have to make a change. You have to realize to try to get it to only sines. That way you can factor it and solve. That was a hard one too. Okay, which brings us to number 13. Now, number 13 is not fun. So let's just go ahead and dive right in. Sine x over 2 plus cosine equals 1. You're going to have to change something. You can't have both sine and cosine. That's not going to work. So you're going to have to change this sine x over 2. All right. And so sine x over 2 will become this right here. So you can change it to a plus minus root of 1 minus cosine x over 2. All right, and then I've got my whole plus cosine x equals to 1. Okay, now this is going to get weird, so just do the best you can to stay with me here. I'm going to move cosine x. I'm going to isolate this root. And the reason is because I don't like roots. And I'm going to have to, this on the right side, it'll become 1 minus cosine x. I'm going to have to cancel this root by squaring both sides. So on the left side, well, it's easy. It just becomes 1 minus cosine x over 2. But on the right side, you have to FOIL that out. So you would get 1 minus 2 cosine x plus cosine squared. Okay. Now, I don't like this over 2. So you can think of it as cross-multiplying, or you can think of it as just cancel the 2 by timesing both sides of the equation by 2. So you're going to have to distribute on the right side. So on the left side, it just becomes 1 minus cosine. On the right side, it becomes 2 minus 4 cosine plus 2 cosine squared. All right, now I would treat it like a trinomial and get everything to one side so I could factor it. I move towards the square in order to keep its coefficient positive. So if you rewrite this problem right now, you could get 2 cosine squared minus 3 cosine x, because I added cosine to both sides. And then plus 1 equals to 0, because I subtracted 1. So if you get here, you can treat it like a trinomial and factor it and finish it out the same way we did last problem. So it'd look like this. All right, there's no number in my B slot, so I really don't care about the whole 2 pi n situations. So this one, you're just going to set it equal to 0 and solve it. So like add 1 divided by 2, you'd end up with cosine x equals 1/2. And then this one, you would set it equal to 0, same. Add 1, so you get like cosine x equals 1. All right, the one on the left, when you go to inverse cosine it, it's positive, so it's going to have an answer in quadrant 1 and in quadrant 4. And so in quadrant 1, that would be pi over 3. And in quadrant 4, that would be 5 pi over 3. So there's 2 of my answers. And then over here where it says cosine x equals 1, when you inverse cosine that, it's basically giving you the x value. So it would have to be at 1, 0, which is at 0, or 0 pi. Same thing. So that's how you solve those multiple angle equations. You're going to have to be changing stuff. You're going to have to pay attention to pi n, 2 pi n's. You're going to have to be able to factor. These get really difficult. So I hope this video helped.